Hello and welcome to the tech side of my Minesweeper video. Hopefully at this point you've watched the main video. If you haven't, I'll link it here and in the description below. So in these tech videos, I try and go into a little bit more depth on the actual technical side of what I did, while the main videos are sort of intended for a general audience, so kind of everybody can enjoy the tech, and if you really want the details, here they are. So, as I showed in the initial video, I'm using a neural net. What I didn't mention is that this is actually from the Keras framework using TensorFlow. The input space I show as the Minesweeper window. What I don't mention is that Minesweeper window is actually getting turned into a one-hot encoding. So basically, I take the initial window, I split it up into tiles. Each of those tiles gets run through a convolutional neural network to figure out what's there. In this case, because Minesweeper uses the same tiles regardless of what time you're looking at a different one or two, it's a very simple training process. After I have that, I actually embed it in a slightly larger padded matrix so that the outer edges are zero filled, basically. I run this into a one-hot encoding so that each of the tiles is actually represented by a vector with size 11. And the reason you do this is because we want to be able to indicate a specific tile. As far as the neural network is concerned, there's really nothing different between a 1 and a 2. Like, it doesn't know that a 2 is any larger than a 1. So this way, we don't kind of accidentally give the idea that an empty space somehow has a numeric value. We don't want to do that. The one-hot encoding deals with this issue very nicely. The side effect of that, though, is it takes a little more data to train. After that, I showed the simplified neural network in the main video. I'll throw that on screen here, where I'm calculating the probability as the output of the neural net. Basically, in this case, this is the probability that if you click on that square, you'll die. We know what the probability of this is for a specific training case, because whenever you lose the game, you actually get a map of the mines out. So we basically have the true data, which is 0 and 1, and then we ask the neural net to try and predict whether there's going to be a 0 or a 1 in those locations by using an output that's in a real space. We actually get something that's essentially the probability out. Whenever I've run tests on this, it's turned out it's precisely the probability out, so it's a pretty good system. I believe I am using a classification layer here, so it should give us a good result. The next thing I should mention is I make it seem like neural nets are one giant box. Actually, they're not. So on screen here, I'll throw something that looks like the real architecture. As you can see, there's actually 3 different CNN layers present. The first layer has 24 filters in it, the second layer 16 filters, and the third layer 64 filters. As you can see, the output space is an image space, so we're doing an image-to-image neural network calculation, so that output space at the end has to get compressed down. Basically, we need to flatten all of the features, and we do this by having an additional convolution, which is actually a 1x1 filter, and the weights on that are learned by the network. And this gets us back down to the right size of model. So I think maybe the only other kind of really important thing that I did during this training process was something actually suggested by somebody in the community who was watching my Twitch live stream when I was developing this, and that was that the activation function used in the intermediate layers is actually a sigmoid function. Initially I was using a ReLU function, and the convergence was just incredibly slow. Probably this was a vanishing gradient issue, but at the same time, by making this a sigmoid, we basically make it really easy for the neural network to identify whether a specific pattern is present or not. Generally speaking, that's how I think it's useful to think of these. So each of the layers is a 5x5 filter, so we're essentially learning in the first layer 24 different 5x5 shapes. Now, given that I'm using a one-hot encoding with 10 inputs, 5x5 shapes should be way too little. So you might ask, how did I do my hyperparameter training? How did I decide on this architecture? And the short answer is I did the standard hyperparameter search. It was on the expert difficulty that I did it. I then used that same setting on all of the other difficulties, but basically I just tried a whole bunch of different network configurations systematically and figured out the best one with the data set I had at the time. And I reused that on all of the difficulty settings. So to me, it's a little weird that I only need 24 filters in the first layer, but factually, with the data set I initially had, this was the best performance I got. I'm sure that if I really boosted performance much further by having much larger data sets, probably a different network would be optimal, but this got, I thought, pretty good performance, and to be honest, given the simplicity of this network, that it doesn't really plan ahead, probably this is the best approach as is. Is there anything else I should mention? There really wasn't any regularization. The dropout layers I found were pretty harmful on it, so basically a very simple network. The only thing I think is kind of interesting about it is that it's an image-to-image network rather than going to a single output, but Keras actually supports this pretty naturally. The only other thing I would say is this project is being done in Python rather than in MATLAB, and the main reason is I couldn't actually figure out how to do this image-to-image calculation in MATLAB. So anyway, if you like the technical side of this, I'm going to release one of these for each of the videos coming up, and additionally, I'm going to be doing live development of these, so feel free to come by my Twitch. It's at the moment live 5 days a week in the afternoon for North America. So if you like that kind of thing, come talk to me about this and maybe yell at me a little bit about silly decisions I made. Honestly, this is such a good learning experience for me. I hope it is for you too, and I'll see you guys next time. Thanks.